So let's now go through an example of writing a Boolean expression using the logic notation and writing the same expression using gates. So here is one example Boolean expression, x and y or x and z. Okay, so this is an expression written using Boolean variables. So x and y and z, these are the variables, and or, these are the operators, right? And again, we've added brackets so you know which order to do them in. So I'd like to create a circuit that does the exact same, that implements this formula here, right? So I'll give the output a name, so I'll call Q. Q is usually referred to as the output of a logic expression. I'm not sure why, that's just what the notation is. So what we do is we list all the input variables, and then we draw gates to implement these operations here. So I've got three inputs, I've got an X input, a Y input, and a Z input. And then I've got to draw gates and draw wires such that the output Q implements this operation here. So the first thing I've got to do is I've got to compute X and Y. So I'm going to draw an AND gate, which is this gate here. And it takes X, and it takes Y, and then logically ANDs them together. I've also got to compute the logical AND of X and Z, so I'll do that too. And I can always attach wires together, so I'm going to make a joining wire here. So here, X connects to all these wires here, but these two wires don't touch. So you put a dot where there's a junction, and then we logically AND it with Z. Okay? So the output of this is X and Y, and the output of this is X and Z, and then we've got to logically OR them together. So I'll draw an OR gate, connect these two together, and then label the output Q. There we go. This logical expression here is equivalent to this circuit here. So now let's do an example going backwards. I'll draw a logical circuit, and we'll try and derive the Boolean expression for it. So I'll write some variables, and then I'll just draw some gates willy-nilly. Now I'll draw another gate. And some more gates. Okay, there you go. That's my circuit. So now I've got to try and express this as a Boolean expression. So an easy way to do this is you can label each of the wires in between with a temporary variable, and then proceed one step at a time. So I'm going to label this T1, T2, T3, and then I can sort of work backwards from Q. So we can see Q is equal to Z, logical OR T3. Okay, I know what Z is. Z is one of my input variables. What's T3? So T3 is equal to T1 logical OR T2. Now I'm going to write expressions for T1 and T2. T1 is X XOR Y. And T2 is X and Y, because T2 is on the output of this AND gate, and X and Y are the inputs. So T2 equals X and Y. And now I can just substitute everything in, right? So Q is equal to Z or T3, which is equal to Z or, what was T3? It was T1 or T2. So we do the OR first. And you always want to put brackets, otherwise you might. I mean, here I'm not introducing ambiguities, but I might. T1 is X, X, or Y. Logical OR T2. T2 was X and Y. Okay? Now, because a logical OR is associative, that is, if you have A or B or C, and you bracket it this way, or you bracket it this way, the end result is actually the same. We can actually drop this set of brackets here. And there we go. So this would be the Boolean expression for this circuit here. So now I'd like you to have a go So for this expression, draw the circuit, and for this circuit, draw the expression. So I'll let Q equal to X and Y and not Z, or X and Y. So convert this to a circuit. And then take this circuit, just draw some random circuit, X, Y, Z. Okay, write the expression for this circuit. So have a go at that, and then we'll go through the solution in the next video.